So good morning. This is a video lecture on projectile motion. So we're done with free fall. So free fall is just a state wherein an object is falling freely to the ground. So without any outside force. So the only force that exists that tries to influence the object is gravity. So as the object falls to the ground, it accelerates due to gravity, which is around 9.8 meters per second squared. Now, projectile motion is just the same as free fall motion. However, it is a two-dimensional motion. So if this is our free fall, so an object falling freely to the ground, so that is a vertical motion. So it is only a one-dimensional motion. So if you observe here a soccer ball falling to the ground, if you observe the acceleration is 9.8 meters per second squared, and its velocity from a zero velocity initial, it then increases. So it accelerates at 9.8 meters per second squared, meaning the velocity will increase by 9.8 meters per second for every seconds. So this is a one-dimensional motion, meaning it is only moving in the y-axis. So y ra ang iyang motion. And projectile motion, this is an example of a projectile motion. So it is a two-dimensional motion involving a constant horizontal motion. So there is a movement sideways, which is constant, meaning the velocity did not change, and a vertical motion wherein the acceleration or the velocity increases. So there is the presence now of acceleration. And again, that acceleration is due to gravity. So the value of the acceleration is 9.8 meters per second squared, meaning the velocity again will increase by 9.8 per second meters per seconds for every seconds. So the characteristics of projectile motion is that it has horizontal motion, and that motion is having a constant velocity. So you could see it from here sa diagram sa right or sa GIF sa right, that if there is no gravity, then the object will have to move the back kaning green nga ball. So if there is no gravity, it should have moved straight to the right. But since there is gravity, so gravity now somehow pulls the object down. So there is a combination of a sideways motion, a motion to the right, and a motion downward. So the result would be is a path that is a curved path. So again, mao ni siya ang characteristic niya. Na siya horizontal motion to the right, and then it has a vertical motion. Again, it is accelerating at 9.8 meters per second squared. So if you observe, kung ato ni siyang i-pause ang diagram, so you would see that um, whichever is the new position of the ball sa kaninga curve path, that is always aligned with vertically aligned with, as if it falls under only the influence of gravity. So ini-align siya diri dapita. And then sa iyang kwan, so it aligns here, and then this one aligns here. So meaning to say, the acceleration due to gravity is not affected by the horizontal motion. And the horizontal motion also is not affected by the vertical motion. Meaning to say, both motion is independent from each other or does not affect each other. So if you observe from here, so you can see the lines here shows, so these lines here shows, kani siya nga mga line, shows that the distance between each line is constant, meaning the velocity is constant. Meaning, there was no time that, uh, there was no instant that the velocity is higher than the previous one. So meaning to say, the velocity at this point right here is just the same as the velocity from this point to this point. So that is, you can see that one constant. And if you can see it from here also, the vertical motion, if you observe, the lines increases in distance. Di pala? So, ang iyang distance nagkataas. So if you observe from here, nagkataas na ang iyang distance. Meaning to say that the velocity for every second increases. Okay, let us say the velocity here is like um, small distance, and the same time, let us say 1 second. Let us say for every line here, for every to say capture of the ball here, screen capture of the ball here, that takes 1 second. So for every second, if you observe, the distances between them increases. So meaning to say, the velocity at this point right here is less than the velocity right here, because this one covers longer distance at the same time interval. So from by then we could say that the velocity here is smaller and the velocity here is bigger. Therefore, there is an increase in velocity. And numerically, that velocity increases by 9.8 meters per second for every second. So again, the position of the ball in the curved graph corresponds to the same position as if it falls straight to the ground. So that is the characteristic of a projectile motion. So, so we have two motions, the vertical and the horizontal motion. So we could say that the horizontal motion is only having a constant velocity. So this is the formula for a constant velocity, wherein velocity is equal to distance over time. And then if you observe again, you were able to meet again the kinematic equation. This one is for the vertical motion. So for example, in when we now convert, let us say when we now convert the kinematic equation in terms of projectile motion, there is a little changes in the convention of the variables. So you can see it from here that there is a presence of y. That means that refers to the vertical position, the position right here, the vertical position. And then you also see the presence of x here. That means that is, or that refers to the horizontal uh, axis. So this horizontal motion only has dx, and you also have here the velocity in dx. So there is a difference between vx here and vy. So and vy also here is designated by an initial velocity in the y and final velocity in the y and initial velocity in the y. So again, this motion here is independent from this right here. And this motion, the horizontal motion, does not influence the vertical motion or does not affect the vertical motion. And the vertical motion also does not affect the horizontal motion. So you have here again y's here. And again, the acceleration due to gravity is replaced by g, which is 9.8 meters per second squared. So let us go over with the variable here and identify as where these variables are located in our, let's say, diagram. So Vx here is the initial velocity in the x. So that is the velocity sideways. That is this velocity right here. If you are referring to this diagram on the left. So if you observe that the velocity, this velocity right here in terms of length did not change, meaning to say the velocity is constant. So this is from our first characteristic of projectile motion, is that horizontal motion is has a constant velocity. So therefore, if it has a constant velocity, then its initial velocity Vix should be equal to the final velocity Vfx, because you can see it from here that the velocity is constant. And then dx right here, this dx that you can see from the formula is that distance from the starting point horizontally to the end point. So that is this distance right here. And then that time referred by this equation right here is the time from the start. So it started at 0, time is equal to 0. And then the final time will be right here. And that is the final time is just equal to the time it took for the ball to move from this position right here to that final position right here. And in terms of the vertical motion, so as you can see there, the length of the arrow there, or the velocity in the y, increases as it falls to the ground. So it increases its velocity as it falls to the ground because that is accelerating. So in terms of distance, so dy here is referred to this position right here, or this location of the diagram. So that is from the starting point, which is certain meters above the ground, to the ground. So that is dy. So that is different from dy. dy was here, that distance there. I mean dx is there, and dy is here. And then initial velocity in the y, so at time 0, initial velocity is 0. So there is no motion when the time started. So again, initial velocity in the y is 0. And following the second characteristics of projectile motion is that vertical motion is accelerating at 9.8 meters per second squared. Therefore, the velocity increases by 9.8 meters per second for every second. So at this particular position right here of the ball, you could say that the velocity here, or the final velocity at this point right here, is greater than the initial velocity because the velocity is increasing. So let us now do some practice problems. So a ball rolls horizontally at 4 meters per second. So the ball here, the initial velocity in the x, or vx, is 4 meters per second. So the ball is moving to the right at 4 meters per second. There is a horizontal velocity to the right. And fell following a curved path just like this one. The tabletop is around 1.25 meters from the ground. So the height of the table, which is this one, this is dy, is 1.25 meters from the ground. So question now is, how far horizontally will the ball reach? So we are asked of dx. So this one right here. So we have formulas here that you can use. So we are trying to compute for the value dx. So rearranging that equation, we will have dx is equal to vx times time. That is cross multiply. Next is time. We are not given with time. We are not given with time. Again, there is a given always, but that is not directly given, the value of acceleration, which is 9.8 meters per second. So the value of g is 9.8 meters per second squared, which is not bluntly written or directly written. And then, so we need to find an equation for time from these three equations. Now before, during our free fall equations, we have four equations. And this time we already eliminate the second equation because there is no value of g there, or acceleration value variable there. So we just eliminate that equation. So we are left with three equations now. All equations has g, so that is applicable to our accelerated motion. So the value of time, so we are given with dy, which is 1.25 meters, and we are also given with 9.8 meters per second squared. So which formula on the vertical motion side are we going to use to compute for time? So the first equation, can we use the first equation? Are we given with the final velocity? No, we are not given with the final velocity. We're only given with the initial velocity, which is 0. But we are not given with final velocity, so we cannot use this equation. Next, can we use the second equation? Are we given with dy? Yes, we are given with dy, 1.25 meters. And this one, since initial velocity in the y is 0, so we are left with time and g. Are we given with the value of time? No. So we are going to compute the value of time using dy and g value. So we can use this equation. Can we use this equation? No, because there is no time here. We cannot use this one. Cannot use this equation. So we can use the second equation to compute for time. So rearranging this equation now will result to this square root of 2d over g. So to rearrange that equation, that is cross multiply, we have now 2dy equals gt squared, and then over g, then we are left with t squared equals 2dy over g. Then to remove the square, you just get the root, so the square root of 2d over g. This 2d is 2dy, so that is the distance in the y. So again, do not confuse yourselves with dx. This one is dy, since this one is the height of the table. So substituting now values, we have the velocity in the x, which is 4 meters per second, times 2 times 125 divided by 9.8 square root. So the answer is around 2.02 meters. No, that's not meters per second squared, but meters only. So again, that is meters only. And then another variable to solve, what is the velocity just before it hits the ground? So we are asked, what is the velocity at this portion right here? Again, we are asked of the vertical velocity or the vertical final velocity. So vertical meaning y, so we are asked of this one right here or this one right here. So we cannot use the second formula. We can either use first formula or the third formula. So let us now check if the given is sufficient for the first formula. So we are to compute the final velocity. We can use this formula. Are we given with time or we are not given with time? We did not compute for time. We immediately insert the time equation to the formula, to the previous formula. So since we were not able to compute for the time, so we will just use this formula right here. Okay, so we are given with g, we are given with dy, and this one initial velocity is already 0. So we can solve for vy, b final y. So this is the original equation. So without the y's, so just think of this one as the velocity final in the y. So we transpose this one to the other side, so that becomes plus. And then since there is a square here, so we get the square root of the equation. So we now have substituting values, that is 2 times 9.8 times 1.25 plus zeros because initial velocity in the y is 0. So the answer now is 4.95 meters per second. So at before it hits the ground, the velocity or the final velocity is around 4.95 meters per second. So that would be all for. I have here another problem for you to look into or for you to answer. Okay, this one. A plane drops a package of supplies to a party of explorers as shown in figure 4.15. If the plane is traveling horizontally at 40 meters per second and is 100 meters above the ground, letter A, where does the package strike the ground relative to the point where it to the point at which it is released? So if it releases at this point, so where will it land? Again, if it releases the package at this instant right here, so where will it land with reference to the initial position right here? So this, I'll say this is a zero position. So where will it land? How many meters is it from the zero position? And then the next question is how long will it reach the ground? So with a height of 100 meters, so how long will it reach the ground from the time that the package was released? How many seconds will it reach the ground? So you have more than 30 minutes to answer as a practice for this one. So